Hello everybody, it is 1 o'clock, so I'm about to get started here with our troubleshooting seminar for SolidWorks. This will be a presentation style, so no reason to click along. And what I'm hoping to show you today is not how to never have problems in your SolidWorks files. It's more for what the methodology is for when you do run across issues inside of a SolidWorks file. One thing is having SolidWorks check to see if your geometry is okay by default. So what I'm going to do is I'm going to start just a blank part here. And I'm going to go into the options because I want to show you a system option. Under performance, there's this option, verification on rebuild, that I have checked on. Unfortunately, that is turned off by default in SolidWorks. So it's under your system options, performance. This is usually turned off. The reason they have it turned off is so that SolidWorks can build your parts faster. It's not always checking to see if the geometry is correct. However, if you don't have this checked on, you're going to see that you can have errors and never even know about them. So I'm going to turn off this option, the verification on rebuild. Say okay, and I'm going to start building a part. So pretty simple one. I'll just draw a box here, put some dimensions. Extrude it out. All right, so I'm just going to continue building some features here, nothing too special. The construction line, circle. I'll cut that through. Okay, I'm almost done. I just got a couple more features here that I want to do. I want to put in a fillet. So I'll put something back there, and then I'll shell it out. Okay. So that's my basic part. The first thing I want to talk about is rebuild errors and understanding what's going on there. So whenever you make a change to a part, like if I double click this original extrusion and I change the height on it, all right, I changed the dimension, but the geometry didn't change. You can see over here in your feature manager tree, there's a little stoplight. It starts collecting those as you put in changes. If you just hit the green check mark, it never changes anything. It just starts tagging all the features that you've made changes to. And so that's what this rebuild button up is here for is. There's a couple of hotkeys you should know. One is Control R, which is a redraw. That's only if you've got like ghosted artifacts or something like that. You drag something across the screen and it leaves a bunch of ghosts behind it. You do Control R, it'll redraw the screen for you, but it doesn't actually do anything to the geometry. It's just updating your visuals. When I hit Control B or press this button, what it's going to do is it's going to go through the feature manager tree, look for anything that's got that mark there, and rebuild those. You can rebuild as you go. If I do the same thing, I click on this dimension. In the Modify box, if you hit this little rebuild, it'll rebuild that dimension so you can see what it looks like before you accept it. Because otherwise, if you just hit the green check mark, it takes into account that change, but it doesn't actually change anything. Yes, sir. They are. I'm not really sure on how to get those off. No, sorry about that. I can make sure my stuff's here. I usually have two screens but for some reason, just give me one screen today. Sorry about the names down at the bottom. Okay. So again, as you're going through here, you can change these dimensions. If you hit rebuild, it'll actually make that change. So by hitting this little stoplight, before I accept the change, I can actually see the change in real time. Okay, so that's what's up with the rebuild. So usually it is a manual process on the rebuild. You actually have to hit rebuild to get it to happen. Sometimes rebuilds have to happen just for it to figure out what's going on. Like if I reorder these things, you see I can change when the cut and the fillet happens. If you watch really closely for a split second, there's a couple of rebuild icons on those things. What it's done is it took a look at those features and it had to rebuild because that's such a big change to the part that it quickly rebuilds things. So if I change when this happens, if the shell happens before the cut doesn't get a wall thickness put on it, right? So you can actually change the design by moving these around. At this point, I rolled the shell up before that fillet happened, so I have a square end at the bottom of the part. Notice I don't have any issues. Even if I rebuild, no problems here. If I were to take this part and do a save as, and just save it out as like a step file, if I do what's called a round trip, where I actually open the part that I just saved, so I have to set it to look for step files. I open this one. That's my, you can put whatever sounds you want in SolidWorks. So I've actually got it to do a little Martin ha-ha whenever I've got some problems on here. When I bring this thing in as an imported part, right away it says, do you want to run diagnostics on this? And bang, there is a ton of errors with this part. Okay, I did it on purpose fast. Okay, that's enough of that. I did it on purpose fast because what's going on here is by switching when this happens, this shell happens before this gets rounded off. And so what's happening is the inside of the shell is sticking out of the back of my fillet. Why did that even happen? It happened because I had turn verification and rebuild turned off. So if I go back into my options and I turn this on, if I say okay and hit rebuild, nothing happens because there's nothing to rebuild. Remember what the rebuild does? It takes a look at your feature manager tree, sees anything that's tagged, and rebuilds those. It looks at my feature manager tree, there's nothing to rebuild. So I told you about two hotkeys already. Control R, rebuild, redraws. Control B, rebuilds. Control Q is a forced regeneration. When you do the rebuild, typically it looks at your feature manager tree and only hits things that have had changes. When you hit a Control Q, it starts from the first feature and goes every feature down, rebuilds every feature, whether it's got a rebuild mark on it or not. And so that is a great way to make sure that your part is valid, especially if you have this verification on rebuild. If I had not turned it on and hit Control Q, nothing would have happened. But because I said, hey, tell me whenever there's a problem, that's where I get those errors. I got to turn that sound off before it drives me nuts. Okay. All right, so it gave me an error. Error goes away. It has to do with where this fillet and shell goes. But that's a really good reason for why you ought to keep that verification on rebuild turned on. What it does is over the course of however long you're working on SolidWorks, every rebuild, it saves you a fraction of a second, which adds up. You know, over a month, maybe you're saving 10 or 15 minutes actual modeling time because your rebuilds are happening so fast. But if one of these errors slips by you and you spend the next 3 days trying to figure out where the error that it never told you about is, you didn't save any time on that verification on rebuild. Also, rebuilds, they don't take that long. The only reason I ever go into this performance and turn this off is if I'm doing some really complex surfacing and the models takes forever to rebuild. I don't want it rebuilding every time I'm making changes and checking it. So I'll turn it off for that. That's really the only time I turn it off. Usually I just run with it turned on so that the minute there's an error, I'm notified and take care of it. And that's another thing on errors. Always take care of them, even if they're the little yellow warnings. 2 kind of errors. Big red ball, I can't even build this. Little yellow triangle, it can build it, but there's some problems. Usually there's some sketch definition or something that's got some problem, but it wasn't enough of a problem for it to not build the part. It was still could build it. But either type of error, whether it's a full error or whether it's just a warning, you really should take care of them right away because they're only going to end up biting you in the ass later on. Yes, sir.
What's the order of operations? Say like if you have your feature tree is full of errors, like with reds and yellows, do you handle the yellows first?
No, it's different from assemblies and drawings. So I'm sorry. His question was, when you do have errors, where do you even start? And that was one of the things I want to do in this class was to show you kind of how to start. When you're talking about a part, you always want to start from the top and work your way down because if I hover over these things, you see these little purple marks, blue marks? Those are parent-child relationship type things. You can turn them on or off if you right-click here, whether you want to see them or not. But that's the reason you want to start at the top. A lot of times errors will come across because the parent has some issue with it. If the parent can't rebuild, none of the children can rebuild either. So trying to start from the bottom and working your way up, you're never going to solve it. So you start with the first error you see in a tree and then work your way down. A lot of times fixing that first error will fix that feature and then all the children of that feature will just be repaired because they have something to build on now. Where before, if that feature isn't building, the faces are gone, the edges are gone, all this stuff that other features might be referencing, they have errors because they can't find that face or that edge. But the second part of your question is at an assembly level, it's different because with the feature manager tree, it's a chronological history in the feature manager tree. But assembly, you can put in different sub-assemblies or parts at any time. There's no like top to bottom history of an assembly. When it comes to an assembly, and I'm going to go through some changes here, you really want to hit the rebuild errors first, which are actual modeling errors. There's 2 kinds of errors you can have in an assembly. You can have a rebuild error with the geometry, or you can have a mate error where it's no longer fitting together. It's, again, one of those cart before the horse type of things where if we fix the geometry, a lot of the times the mates will get fixed because the geometry is back again, where the only reason you had a mate error was because there was a missing face or something. I don't know if I answer your question, but I am going to go through these like step by step to show you the methodology behind it. I just wanted to get this one real simple to tell people what verification on rebuild is, to describe what a rebuild error is, and how to catch them right away. Instead of with that option turned off, you can have a ticking time bomb. Like that file that I had, there was no errors in my feature manager tree. That's why I shipped it out as a step file. I'm going to get a call from a vendor who can't open it because I didn't check it. What you can do, if you don't have the verification on rebuild on, you can still check it. So let's pretend I didn't have this verification on rebuild. Under my evaluate, the same place you find measure and mass, there's an option in here to do a body check right here. If I click on this and check, has no valid edges right now. It's not going to let me do it with the verification on rebuild, but that's the thing you should do. You should hit that check button, regardless of whether you have verification on rebuild or not. Anytime you're going to export something out, if you hit that check, it only takes a couple seconds. It just runs a sweep through all your geometry to make sure that all your faces are valid. If you have any issues in these boxes right here, that's something you're going to need to take care of before you ship it out. Okay. Let's close out of this example and move on to something a little bit more frightening that I'm sure people have seen in the past. You open something like this. You open up the assembly, and all of a sudden you start getting errors. I'm going to have to do this one quick because it's about to dismiss it. It's not matching the internal ID. That's okay. Open whatever you got. The other one, it's unable to locate this file. If I know where that file is, I can browse for it and replace it. What's happened here is it's looking for a file and couldn't find that file. If you know where it is, that option right there, I can say browse for it myself, go look for the file, find it. It opens the assembly. Next time I save the assembly, that new location of the file that I put in there will be remembered. But this can happen sometimes. You open an assembly, you get all these errors. You can view a report. It was unable to locate this file, and it's telling me that, hey, the internal ID doesn't match on one of these files. And I open this thing up, and there's all sorts of missing pieces, which is bad. So what I'm going to do here before I hit save is I'm going to hit close and don't save anything. Because if I save, all those errors are going to be in there. Let's take a look at a couple different ways of looking at a part, even though it's all trash like this one is. I want to see what this assembly looked like before all those pieces were missing. There's a couple of ways of doing it. One way is if I open up the drawing for it. So I'll find the drawing for that assembly. Let me just filter it so I'm only looking for drawings. If I open this up, it's set to resolved. You see where it says mode resolved? That is the typical mode that SolidWorks is in. What it does when you open the drawing is it loads all the parts into RAM, it does a rebuild on it, and then it shows you the drawing. That's going to be problematic here. We already saw that when I open this thing and start rebuilding it, I just get nothing but errors. There's parts missing. There's things it can't figure out. So rather than opening it resolved, if you open up a drawing quick view, that'll open it up without loading up the assembly. All I'm going to get is basically like a PDF. If I say open this thing out in quick view, boom, I'm done. First off, you notice how quick it opens up because it didn't need to load all the assembly and everything. It just loaded that one single part file as it was last saved. So if I zoom in here, hey, look, all the pieces are back. Unfortunately, I can't do much else with this. If you take a look at my toolbars, when you open Quick View, the only thing you can really do is hit print. But it does have its advantages. If you have a part or a drawing that has no part associated with it, anybody ever seen this? Open up a drawing, you got nothing. Okay, same thing. So I'm trying to open up a part drawing here, fully resolved as it is by default. So what SolidWorks does, it opens up the drawing, it goes to load the part up, and it's going to redraw the pictures. It did not get that far. It loaded up the drawing and went to go find the part file, and it couldn't. I had a little message that said, hey, you want to find it yourself? I have no idea where it is. So I'm kind of screwed. This also happens a lot when people just send you a drawing. They don't realize they need to send you the support files. They'll be like, oh, I sent you the drawing. If all you needed to do was open that drawing and print it, you still can. If I find that same drawing and I set it to that quick view choice, I can open up this drawing, print it out. I know what the part looks like. You know, it depends what you're trying to do with your drawing. If all you needed to do was take a look at it, you can do it in quick view. You can't do much else. Can't add notations or anything. All I can do is print it. Okay, there's some other tricks that I can use. One of them is using SolidWorks eDrawing as a viewer. So E-drawings, as long as I didn't save the assembly with all those issues, the issues that I'm getting actually were done at the sub-assembly level. So at the top level assembly, last time it was saved, it was fine. If that's the case, and I go into eDrawings and open it up, eDrawings is a free program with SolidWorks. I can go in, I can open that drawing. Same type of thing. But I can also open up the assembly. So remember before when I tried to open this up, I had a whole bunch of errors and stuff all of a sudden when I was trying to open it up. If all I need to do is open it and take some measurements or something, right there I've got all the parts. Because this is not trying to rebuild. This is opening up as last saved. When you open up an assembly in eDrawings, you can go into the parts and just start moving pieces around if you need to get inside the assembly. So again, if this is a type of thing where all I needed to do was go in and find out how big this was, rather than sitting there spinning my wheels trying to get this assembly fixed, I can go into eDrawings, open the thing up, take the measurement, get out of there, I'm done. I should probably tell somebody, hey, your assembly's all jacked up, but I was able to do my job without actually opening it in SolidWorks. So just to let you know, these eDrawings, they're kind of nice because as long as the error wasn't saved into the file, you're going to open it up as last saved. One more nice thing with SolidWorks, if you do open up an assembly drawing, there's not much you can do with it. But if you open up a drawing of a part, like remember we had this file, so it didn't give me any guff about it couldn't find the file, which is nice. It just opened it. I can print it out. I can start taking measurements. But when it comes to a part file, if I right click on a view and choose to rotate it, it's actually got a solid model in there. So I can open up the drawing, I can bring up the solid, I can start taking measurements off of this solid. Even though, remember back in SolidWorks, I don't have the part. The guy did not send me the part file. I can open up his drawing and start taking a look at his solid model through eDrawings. So just some cheap things using that eDrawing tool to basically give yourself like a historical record of what this looked like when it was saved. And I can even, interrogate it as far as starting to take measurements off of this inside the eDrawings. I can do that. And again, I don't actually have the part file. Nobody sent me that, but I can get the information through eDrawings. Okay. Any questions on the eDrawings? All right. One more setting. So I showed you as far as drawings, we can open up a quick view, which will open it up as drawing was last saved. When it comes to an assembly, that has a little bit of a different style to it, and that's called large design review. So let me just talk about these different styles of modes that you can open your assembly in. Resolved, I already talked about that. That's when it loads everything into RAM, rebuilds it, brings it up. Lightweight, it doesn't bring everything into RAM. It actually just brings in the 3D geometry of it. So it's kind of like bringing in the eDrawing information. But in lightweight or large assembly mode, I can still double click on one of those parts and load it into RAM pretty quickly. This last choice, large design review, it's going to open it up as last saved, but it gives me a little warning here. When you're dealing with a large design review, it's not really for someone who's actually making changes to the design. You would want to load up in SolidWorks. But if you're somebody who's a top-level guy who just needs to know what's the height here, how big around is this, questions like that, you can open it up in this large design review. And let's take a look at what our feature manager tree looks like. You'll see that underneath the feature manager tree, I can't expand that. There's no planes or axes or sketches or anything underneath here. All it's loaded basically is the eDrawing information for me in SolidWorks, where I can still take measurements and things like that. So again, it's another, you're not completely out of luck when somebody sends you files and they don't have the support files. You can use the e-drawings, you can use this large design review, you can take a look at the thing without having to wait for the next day when the guy comes back to the office and you can tell him, hey, dum-dum, send me all the files with that. You know, the assembly was cool, but I need the parts if I actually want to work on them. And here, if I want to create a part, or if I want to look at a part, I can go into a particular component and just load that one part right from the LDR. So it's kind of nice. I can see, take measurements. I can also go into my feature manager tree, see what components are in there, and even open up individual components if I want to work on them. To get out of this large design review, if I just right click and choose to set all to resolved, that's going to load everything into RAM for me. And we're going to get the same issues that I had the first time I tried to open it, as in it can't find some of the components and holy errors. There's a ton of errors. It lists them out for me. This is where we start to get in that triage that you had asked me about, Kelly. You know, where do we even start? So I've got errors. Made errors, coincident, eccentric. I'm not even worried about those right now. I'm only worried about things that say has rebuild error, because that means the geometry is messed up. I want to take care of the geometry first. Again, it's one of those chicken and egg things. If I try and fix all the mates when the geometry is not there, I'm going to be chasing my tail. I have to fix the geometry first. And a lot of times when you do that, the mates will solve themselves. The only reason the mate was in error was because it didn't have the face that it was looking for. All right, one more thing also, you can turn this off, the show warnings. Just be aware that if you tell it not to show you, it'll stop showing you that, just like you asked. In my options, there's a spot here for ignored warnings. If you turned off these errors on rebuild, you have to check them back on to get them to work again. Also, here's a list of anything you said you didn't want to see again. If you want to see it again, just check it on. It'll come back. But it'll start building a list. So every time you say, don't show me this again, that's where that goes into the list there. You can turn it back on later. All right. But this thing is pretty screwed up. So when I do that rebuild, I want to take a look at 150 and 160 are the two that have rebuild errors. I can also see that without running that report. If I just open this up, when you see a red dot here, there's some more to what's going on with the iconography, whether it's an X or an arrow pointing down. When it's an arrow pointing down, it means that the problem isn't really with this file, it's something inside this file. So when you hit the expand, then you want to keep looking for the arrows until you find exactly where the issues are. Yes, sir.
I usually don't get those red arrows that indicate that's, the problems inside the assembly. Where do I go to activate that?
Well, it's going to automatically. You usually get these red X's.
Yeah, I get the X's. I don't get the arrows.
Right. So the difference is the red X is a rebuild error. And the arrow is really showing me, hey, there's something in the mates of this assembly. Because when I look at this one.
Yeah, I get that. But I don't get the red arrow warnings. It'll show an X, that's something wrong with the assembly, but I don't get that red arrow.
Okay. The question is about whether we're getting an X or a red arrow. It should automatically. There isn't really an option where you're like, only show me rebuild errors or only show me mate errors. If the thing has a rebuild error, this trumps the arrow where it's going to be an X, because if there's any rebuild errors in there, it's like, boom, this one's not, I can't rebuild this. Where the other one is kind of like a, hey, the problem's here, but it's not at the top level. But I can take a look at your settings. I'm not really sure how you would get it to not do that. All right, but what I'm going to do is I'm going to steer clear of this one because I saw that this one was just a problem with the mates, and I saw that this one is just a problem with some of the parts inside of the assembly. Where these two right here, whenever you see a red X, that is the big problem. So let's solve it one big problem at a time. I'm going to skip these that are just mate errors and go right to the one that's a rebuild error. That was one of the ones that was listed in the list of things that it couldn't find. So here's a part that is suppressed. How that happened is there's two ways that a part assembly can open up with parts suppressed. One way is if it can't find the file name, it's going to find it as suppressed. The other way is if the internal IDs do not match. This one was an internal ID match issue. And what that means is if you build a part, here's my part, let's just call it cylinder 1. I'm working on the part and then I realize, this thing was just built all wrong. I'm going to build another one correctly, give it the same name. You can do that, but when the assembly goes to open it, every SolidWorks file gets marked with certain indicators. What machine was it drawn on? What date did it get started on? These types of things. Whenever SolidWorks opens an assembly, it checks all those first. And it says, hey, this part called cylinder 1 is not the one that was created on April. This is the one that you created in August. Is that okay? That was one of the questions that it asked me when I first opened this assembly. It said the internal IDs do not match. I just panicked and said, yeah, just suppress it, because I didn't know what it was talking about. Here I'm going to take a look at it specifically. If I right click and open the suppressed part, that is a great sign. That means at least I have the thing on my machine. So I'll go back into the assembly. Let's unsuppress it. And that's when it gives me that warning again. So this is the one that has the internal ID of this does not match the original one. I'll accept this file anyways. If I say open without this file, it'll just leave it suppressed. That's what it did the first time I opened it. But there we go. I opened it and it seemed to give me more errors. So again, you can take a look at what's going on here. It looks like all these mates are mate errors because I've got these arrows pointing down rather than red X's. So it's just a matter of me figuring out which mates go on what. For an individual part that has mate errors, you can right click on it and say view mate errors, and it'll show me every single mate that's on there. Now, because this part had a different internal ID than the original, all the faces and everything have different names. All the edges have different names. So all those mates that were mated to the original part, they're no good anymore. I can go through individually and edit this, delete the missing face, and replace it with some other face on the part. And that just brought it down by 1. So I can go through that list one by one and then reattach each one of them. But you can also group select them and just blow them away if you want. Okay, because this one is just in the wrong orientation. It was modeled differently than the original. The part is fixed in space. It's got that one mate that I did repair. I'll just get rid of all the mates. But this part won't move. The first part that you bring in to an assembly is always fixed in space. It has to do with the fact that SolidWorks can do dynamic motion. You need to hold one of the parts still so that when you pull the lever or twist the handle or something like that, the whole assembly just doesn't flop into space. So one of the parts is fixed. In this case, it's the one I want to move, which is unfortunate because I can't move it. So before I can move it, I need to float this. If I right-click, float and fix is just a toggle. And now you see this thing's free to move. Undo is always nice because you don't want to move it like that. I want to move this thing a specific amount. I just want to rotate this thing 90 degrees. And I'm worried since all this stuff, none of it's really made it into place anymore. I suppressed the float or the fix. So everything's going to start moving on its own now. I don't have anything that's cemented to ground at this point. Okay, if you have a part that is free to move, you can right click on that part and there's a choice called Move with Triad. Brings up this little triad. I can either hit these hoops or click and drag on these arrows, moving them axially or rotationally. I can just eyeball it in if I want. I can just click and drag and say, yeah, that's about good enough. Or once you've got this triad up, you can right click on it and you can bring up a delta X, delta Y, delta rotate. Like this, I could say, I'd like to rotate this thing 90 degrees about the Y. Bang, done. And then just click somewhere off the place. You need to, so when you right click on something, if you see this move with Triad, it'll always bring that up. And if you've brought up any of those delta X, delta Ys, they'll stay on until you turn them off again. But now that I've got this thing sort of oriented correctly, I can at least put it in the right position and then fix it again. Okay, I've got another part here that seems to have some issues. That issue is because I got rid of all those mates. That's fine. I'll just put this one back on. But the other issue I have is these parts running into one another. So SolidWorks doesn't warn you about interference automatically. You have to check for that yourself. If you go onto your evaluate, there is a place where you can go to interference detection and have it calculate where our interferences are. And it'll show us if we have any. But my biggest interference is right here. Got too many ribs on this part. I want to make some changes to this part. And the first problem I have is it's got too many ribs. They go too high up, so I want to change that. Luckily, these were done with a pattern. So they made one rib and then they patterned it, which is fine. But what I wanted to show you was there's a couple of different ways of creating patterns. And this is new in 16. You used to only be able to say, okay, I got this many and they're this space apart. But in 16, they gave us this up to reference option. What the up to reference allows me to do is I can say I want it to go up to here. And you'll see it'll figure out how many times that it'll take to get up to that face. But then I want to say I also need 10 millimeters offset from the top. So you can have it go up to this face until such a distance so you don't get like half circles and things like that that you will often do when you do patterns like a linear pattern all the way down a bar. It's going to give you a half a hole at the end unless you offset it towards the end. Also, when you are doing this up to reference, you have two choices. Right now, it's going to figure how many from 10 below this to this piece it can fit in there at 9 millimeters apart from each other. So if I start changing this number, it'll figure out how many it's got to put in there to give me equal spacing. Or, so I either set the spacing or I can set the number. I want to make sure I have 12 in there, and you'll see it'll change the spacing depending on how many you would like. So it's nice because it's, instead of me typing in a hard number, I can say, hey, go up to this face or almost to this face, and then it'll always recalculate. As I make the thing bigger or smaller, I don't have to worry about do the fins fit in there. The pattern's going to be doing that itself. Oops, there we go. Okay, that does not look right. Back in here. The feature. Oh, that's because the distance I want is 9. There we go. Okay, so I fixed that part. Another thing is I want to make this bore a little bigger. So I double click on it. It is parametric, so I can go ahead and change this. And you see it just gets a little bigger. The problem is I got this wall here that when I make this thing too big, if I change this to 140, it cuts off that face. Or even if I set it to 138, there we go. That's even worse. Now I got this little knife face here. Okay. What do you do about situations like this? So there can be some design situations that you've got where you want to make sure that something has a certain amount of material or a certain amount of thickness or something like that. You can set something called a sensor in SolidWorks to give you an alert when that's no longer the case. Let me put in a dimension here. Here, there. So I have this dimension. Right now this thing is a 0.5 millimeter wide. I want to make sure that it doesn't get under an inch, millimeter and a half. So in my feature manager tree, there's this sensor folder, and you can put on as many sensors as you want. So I'll say, okay, let's add a sensor. And again, I can do different types of things. I can do a mass property, like if it gets this heavy, let me know. If it gets this light, let me know. Things like that. For this one, I'm going to say I want a dimension. What I'm going to set for the alert is if this is less than 1.5, let me know. And when I rebuild, it comes across as a warning. So usually when you get these warnings, they have to do with errors that you've gotten. If you've set up a sensor, you can also get those come up in the list. Like, hey, this thing is less than 1.5 millimeters, which is nice to know because I can't do that. I need this to be thicker. So if I go and change this thing to, let's say, 140, still got a problem. Now I don't have a problem. So you see that when I was hitting rebuild, I kept getting errors. Last time I hit rebuild, I'm over 1.5, so I get no error. So that's what those sensors can do for you. You can set up something like, hey, I want to take a look for this a little later. Okay. One last thing, and I guess I should talk about that when I get into talking about other parts. I still have some errors. You'll see the error went off my first part. I can take a look at where the errors are for the rest of them, and it looks like they're all coming from this area. I can see there's two areas. You can see the parts themselves, or I can go into the mate group. I can start highlighting all these that have red dots on them. And you can see they're all coming from the same part. They're all coming from this part right here. Now what happened here is we had another thing where I swapped out a part. I had a part that was all modeled up. It was fine, but somebody sent me an exported file and said, hey, we're switching it out. Put this one in. So I just swapped them out. All the mates exploded. I'm going to fix the mates, but before I do, I want to talk about when you have an imported geometry. So in your feature manager tree, the very first feature is import. What you can do is you can right click on that import when you first bring the file in and run a diagnosis. It'll look for any faulty faces, and it actually found one. Right here, I've got an issue. Attempt to heal all. If those clear out or turn with a green check mark, that's good news. It fixed that face for me. So it's always a good idea to do that. This part probably would have been fine. I mean, I had it in the assembly and nothing exploded, right? But if I tried to do an STL or something like that and get it 3D printed, then I might run into an issue because I had that faulty face. So it's just a good idea to, whenever you import a file, right-click and run import diagnosis. You do want to do it at the beginning of the process because once you add a feature, now when I right-click, import diagnostics, not a choice. You can only run it when the only thing in the feature manager tree is the import. Once you've imported it, or once you've started modeling on it, it's not going to allow you to do the import. You can bring re-import if somebody sends you and goes, oh, you know what? We made a couple of changes. And you're like, well, that's great. I'm already putting bosses on here. You can actually insert the file. If I right click on an edit on an imported file and go into edit it, it'll have me just browse for it and it puts it back in as the first feature. So if you've got somebody who keeps sending you incremental exports, you can edit that imported feature and bring the new one in. Yes? That would be lovely, but unfortunately it doesn't do it. I think, so his question was, can you just do this where I take my rollback bar and try and trick it into thinking it's just imported? No, come here, come on, roll back. And I don't have it. I think you might be able to do it this way. Nope. It's pretty picky. If I do it that way, can do it. But yeah, once any feature is on there, it's no longer just an imported body. So it has some trouble. Okay, so I still have a ton of mate issues here. This part is not mated in there. All right. Let me right click and go back into that view mate errors. I moved it out of the way first just because when you are going through here and reassigning faces, it's a little easier if the thing's out of the way to begin with. So all I'm doing here is I'm just going in here, editing it. The reason these things have a problem is because they have a face that they're no longer mated to. I can see the original face that it's mated to. It's a concentric. So if I pick something for it to be concentric with, it should be good. And we're starting to get these errors, slowly but surely taken care of. I didn't want it to replace that face with any concentric. It was kind of like, do you want to use this face in the future for concentric mates? I said no. All right, so that's one way of doing it. You can also find the part that's got issues. And just delete those out of there if it's something like a nut and a bolt. Sometimes that's easier just to go in here and put a smart mate or something on it rather than trying to fix it. Because you saw that the fixing it sometimes can be kind of painful. So all I did was if you hold the control key down and drag apart, it allows you to make a copy. If you hold the alt key down and you drag one circular edge to another, it snaps it concentric and coincident. So for this assembly, I was pretty lucky because everything just had to do with mates, where there wasn't much geometry that I needed to change. There was a little bit that I needed to change on this part, but most of it was all mate references. As I'm looking at here, I see on the bottom of this part a problem. Let's talk a little bit about imported parts again. So for this one, I want to open up an IGES file. I talked about running import diagnostics when you bring in a part. It's always a good idea to do so. There is an option whenever you bring in a part. It asks you, do you want to? That's one of those things people often say, don't ask me this again, and then it stops asking you. But by default, it'll always bring in the part and say, do you want to run diagnostics, even if the part came in fine? It's just because it's an imported part, it wants to do it. I say, yes, let's run this. You see, I've got, this one has a giant issue. The other one had some sort of like very small issue along the edge of the face. This one's missing a whole chunk of geometry. This will happen a lot in IGES files. That's what this is. Just because an IGES file is a surface file. And so what it tries to do is knit up the surfaces, close them up, and then fill them into a solid to make the solid file for you. Here, it failed to do that. It can't make a solid because there's a big hole in the part. So I'll attempt to heal all faces, attempt to heal all gaps, and it did it for me. It stuck a big, ugly chunk of gum right in there, spackle style. I said, okay, I can fix it now. So it just needs to plug that hole up. All it's doing here, as far as, you know, what's happening behind the scenes, it's basically going in here and doing a filled surface. It's grabbing all those edges and putting a filled surface in there. So it's not tangent to the faces around it. It is just like a wad of gum. Like, there, that fits in the hole, and then it's able to create that volume for you. When I go into this surface, there's another choice here called delete face, and it's got 3 flavors. If I do the delete and fill, I'm going to get the same thing that I started with. The fill, all it does is it's going to delete the face out of here, and it's going to fill it back up with geometry. If I hit delete, it'll just get rid of that face and leave me where I started off, where there's a hole in the part. But this one's the magic one, delete and patch. What delete and patch does for you is rather than just doing a filled surface, it will extrapolate all the surfaces around it and basically extend them and trim them together. Here, it's much easier for me to just show it. I pick there, I say delete and patch, hole's gone, that's a cylinder, that's a flat face, and they meet right up. So basically it just shot the cylinder down for me, shot the flat face across, trimmed them up, gave me a nice clean surface. Why am I bringing that up? Well, first off, I wanted to hammer home that whole idea of you should run diagnostics on any imported part when it comes in, just as a matter of course. But I also wanted to show you that I don't have to just use that delete face trick on, you know, problematic imports. I've got this little sliver face here. I noted what happened here, it's how this thing was modeled. These 2 faces on the ends, they've got draft on it because it's a cast part. This is where it's falling away from the tangency, and that's why I end up with this gap. This gap is sort of in the draft until it hits right at this point, and then it's no longer there. That's what's going on. Now, when I select a face, I have the option to select all the faces that are around it. I don't really need these 2 big ones, but there's 2 very small faces that I was able to pick easily by doing that. And if I choose this delete and patch, it's nice and flush with the draft faces now. I don't have that groove anymore. So that delete face is not only sort of a panacea for when you're fixing holes, in an imported IGES part, you can do it on any SolidWorks part. Be like, hey, this thing's not flush with this face, just delete that surface out of there and it'll flush it up to whatever face it was with before. So save and close, back to the assembly, and no more big red errors all over the place. Just a nice unerror-filled assembly. Let's go back to the top. So 150, 150, 150, they're all fixed. How come this one's not fixed? Well, again, if you see that red arrow, it's letting me know it's something down inside of it. It had a mate down to there. If I get rid of that mate, now all of those sub-assemblies are fixed. Okay, the other part that it said had rebuild errors was this sub-assembly here. So I'm going to take a look at this one. This one, I have no issues with the mates. That's nice, but I have issues with the part. And here's those two flavors of errors that I was telling you about. The red ball means SolidWorks cannot build that part. It tried to build that part. It just had no idea what you were talking about, so it failed. This little yellow triangle, that's a warning. It tried to build the part. It did build the part, but something was fishy with either one of the reference geometry or something on the sketch. We'll find out about it at the part level when we open it. But let's start with this first part that has the serious error and open this up. Okay. Horrible feature manager tree. So this is one of those ones when you open it up and you're like, wow, I should just throw this away and start over. It doesn't really have 12 errors. Again, most of those errors are coming from the fact that your very first feature is not even there. So a lot of times what I like to do is give it a control Q and rebuild it. When it finds an error, it'll give me two choices. I can continue, which will do nothing for me. I'll just be right where I started. Or if you say stop and repair, what it does is it finds the first error in the feature manager tree, rolls the rollback bar to under that, and says, okay, here's your first error. This sketch contains an open contour. Their errors are usually pretty vague, like check engine or oil low, something like that. Doesn't really give you much help. So we need to dig in to the sketch itself. The one thing the error told me was that the problem was in the sketch. I didn't really understand what it was talking about with open contours, blah, blah, blah. First two words, the sketch has a problem. Okay, let's take a look at the sketch. When you have a sketch that has a problem, when you try to get out of that sketch, it'll tell you, hey, wait, you haven't fixed the problem here yet. But it gives you two warnings. And this is, I usually get to it from here. There's actually, if you go to your tools pull down and go tools, sketch tools, check sketch for feature, way down in the pull downs, you can find this tool, check sketch for feature. But you can also find it just by exiting out of a sketch that has an issue and say, run that tool. What you do is you set what type of feature you're after, and it'll give you an error. It has more than one open contour. Cool. Exact same error it gave me before. I still don't care. I'm going to say okay. The nice thing it does is it shows me where the problems are. So I got a problem in this corner, and I got a problem over here. So, okay, I had a problem here. So when I do a box select, I got a line on top of a line. Remember, if you do a box select and it's blue, it only touches the stuff that's completely inside there. So get rid of that one. There was another problem right here. Very tiny line. That happens a lot, you know, when you're clicking your line. Sometimes you'll end up with a little tail hanging off of the line, and you get something like that. So I deleted both of those. Okay. Let's go and get out of here. Duh. This time I say, okay, there's still a problem. Open and close contours. At least it's a different error. But I say, okay, it's not showing me where the problem is. Okay. There's a couple of times you can use the F key to help you solve issues. F key is fit screen. One problem is when you're in a sketch and you've evaluated the sketch and you don't see the problem, try hitting F. What is this doing out here? So it didn't really see that to flag it like, hey, this is an obvious error. It didn't know whether I wanted the square or the line. So it just told me, hey, you've got one open and one closed contour, but it didn't show me where they were. By hitting that F, I zoom out to fit the sketch onto my whole screen. Then I can see problems I might not have seen before. This also might help when you're in an assembly and it seems like things aren't right. If you hit fit screen and everything gets really small, you probably got a part like half a kilometer away from another part, and that can jack up your screen. So that Control F sometimes can help us out. When I hit F now, you just zoom up. Let's exit out of it. And hey, what do you know? It built the first feature. Hooray. But just to get back to Kelly's earlier question about how do you even start, when it comes to assemblies, it's a little different because you want to hit your rebuild errors first and then your made errors second. When you're talking about a part, you want to start from the very top of the tree and work your way down. So it stopped me at my first error and said, okay, I can't continue until you fix this. I fixed it. I'm going to right click and say roll to end. I should be done right. I'm not done. Okay, let's stop and repair this one. So it rolls till it finds the next error and then says, okay, here's your next problem. And it even gives me a problem for that particular error. The radius of the fillet is too large. Hey, that one was pretty succinct. All right, it kept going on, but that's all I care about. And you're right, this thing was only like 30 across, so 22 millimeter, not going to fit in there. How about a 2? That'll fit in there. Okay, roll to end, and it's fixed. I have no errors. But that doesn't mean that I'm done. Not all errors are going to show up with an error, kind of like that really thin wall error that I was getting before, where it wasn't going to tell me until I looked at it. You know, I had to draw attention. I could run that thickness tool. I could set up a sensor, that sort of thing. For this one, what they're doing here, if we roll back, is they created a plate and then they created a tool, and there's a tool called indent that basically knocks one shape into another. So it's just like pushing that one body into the other. Body. But then at one point they had deleted that extra body. That got suppressed somehow. I'll unsuppress it. There we go. That's the part that I actually want. I don't need that forming tool stuck in there. So sometimes you just have to take a look on your own, just like I did with that thin wall, or here where I've got an extra body. So your eyeballs on the video screen can help you out a lot too. Okay, so I still have an error. Let's open up this part. Again, a yellow error is not as pressing. It was able to build the part, but you'll see here's where the error is. Anytime you see these down arrows, it's letting you know, hey, keep going. Once you hit the exclamation point, that's where the error is. So let me go into this sketch and take a look. Okay, it's overdefined. If you didn't see all these faces down at the bottom of my screen here, there'd be a thing that says overdefined right there. It doesn't take much to overdefine it. You just keep putting on dimensions. You know, it's blue when it's underdefined. It's black when it's fully defined. If you keep putting on dimensions after it's turned black, you're going to get an error. There's several different kinds of errors. There's a red error, which it can't begin to even figure out what you're talking about when you see a red geometry in your sketch for the error. When you see yellow or brown, this color, it's just unable to solve it. It knows what you're talking about, but which one do you want? Do you want this to be 20 or do you want that to be 21? They're in conflict with one another. At the bottom of my screen here, I've got this overdefined. If I click on it Again, sorry about these faces here, but it says over defined. If you double click where it says over defined at the bottom of the screen, it'll actually bring up this sketch expert for you. What the sketch expert allows me to do is I can say, okay, you obviously think there's a problem with the sketch. Tell me what the problem is. So it diagnosed it and it came up with 8 different solutions that I can go for. And you'll see I can toggle through them. You see how this is moving? Here, it says you can get rid of that dimension, or you can get rid of that tangency. I can get rid of that tangency. So you can move through here and see which ones. It says if you get rid of one of these, the rest of them will be fine. So I just have to pick the one that I wanted. Okay, I don't care about that radius. I'm more concerned with this angle. When I say accept it, it deletes that dimension out of there, and now the sketch is no longer over-defined. And there we go. The part's fixed. Okay, and we're back to the assembly. And at this point, all we've got left is mating errors. So let's take a look at this part here. It looks like we got some problems with it mating into those holes correctly. You can actually check for that at the assembly level. I can say I want to check for hole alignment, and I can pick and see which parts I want. Those 3 parts, check for any holes that we've got. And it'll show me anything that's listed here is stuff that is not coming up concentric. So I actually only have one of the holes in the place where I'd like it. But that's what this hole alignment tool you can do. You can pick the 2 parts. It'll find all the holes in one part, all the holes in the other part, and it's just checking to see if the axes line up. If they don't, it flags you and tells you, hey, this hole's no good, this hole's no good, etc. Okay, so this thing's probably just not going to fit in there. It's okay with that part right there, but I'll just suppress that mate and delete this one, because I actually want this thing, whoa, mated like that, yes, but then so my problem is this thing doesn't fit, right? I can get a couple of them on there, but I still have issues here with this thing fitting in. So I can take a measurement quick from center to center and find out what the distance I need to be is. Or the other way I can do it is I can go from here to here. And down at the bottom, you can see the number right here that I need this to be 40 millimeters. Not helping me though. Okay, so let's take a look at what we need here. So sometimes when you're taking a look at this stuff, you can see it's 45 in that direction and 40 in that direction. So that's my problem. Let me take a look at that part again. So if I take a look at this, here's my problem right here. This thing, this square is where what it's using to tie these together. But right now, they're locked to this circle. Because for this, it's not actually going to be a bolt hole pattern, or it's not going to be a bolt circle, I should say. It is still going to be a hole pattern, but I had one was going 45, one was going 40. So that was my issue. So sometimes you do, sometimes it's as easy as just a quick dimensional change. Sometimes you have to go in and really take a look at which dimensions we're talking about. Even in this case, I think I got these backwards. Easy enough for me to change. Let's make this one 45. This one 40. There we go. Now all of a sudden, my errors went away. That was why I was getting those mate errors, was because that thing wasn't going to mate on there between two holes. All right, so that's a little bit about troubleshooting. Hopefully that will help you guys out in the future when you do run into parts that you need to take a look at. What do you do? When it comes to parts, you start from the top and work your way down. When it comes to assemblies, hit the model, the rebuild errors first, and then take care of the mates at the end. All right, let's take a look at this part. Again, if you can hit File and Open, that's great. But if it can't find it and you don't have it, what are you going to do? You only have two choices. You're either going to suppress it, which is what it did by default, or you're going to have to find some file. It doesn't necessarily have to have the same name. It's looking for this one called 100-017. I have no idea where that is, but I do know that in my troubleshooting folder, I have this exhaust pipe. That's what this thing's supposed to be. Close. And now I can unsuppress these, and you'll see that they're no longer that part. Instead, I'm using these exhaust pipes. Oh, great. I just finished getting rid of all the errors, now I get errors again. Okay. Let's take a look at this part. So this part has external references. I can see because right here, at the very top feature on my feature manager tree, if you scroll all the way to the right, if you see this minus sign, greater than sign, that means that this part is looking to another part or assembly for its geometry, which is great when you're in R&D, but at some point you want to get rid of these external references. Also, and we've had this issue come up a couple of times here at Rails. If you've got a part with external references and you put it into your data manager, it's fine at first, but once you've put it into a state where it's released and it's got rev numbers and you can't go backwards or something like that, it becomes problematic to have external references. The reason is that if you've got a part that's released and then there's a part that's got an external reference to it that's not released, they're out of sync. You actually have to take that one that's been released out of release and check them both in at the same time. So you end up revving stuff for no real reason than the fact that it's got an external reference. So it can get pretty ugly. Basically, you want to take external references out before you give it one of those revs. One of those revs has approval. When you're in an R&D phase and you're just prototyping and making different changes, it's great to have an external reference because things will always fit inside. In this case, what's going on is the exhaust tubes fit right up to the bottom of those cylinders because they were designed from the bottoms of those cylinders. And at this point, if I make the cylinders further apart from each other, the exhaust pipe should update because it's got that external reference. But here's the thing. I don't want that external reference anymore. If I go into Edit to Sketch and I say Display Relations, I can have it search all external relations and see all these on edges. Those are what's defining where the edges of this flange goes. I can delete all those. When you delete all of them, you do run the risk of it moving around at this point. It's completely underdefined. There's a couple of things you can do. You can click on here and say fully defined sketch, and that'll put in dimensions to lock it down. You can also box select and just fix everything. That's really cheating because now it's got no dimensions behind it. I can't change it. I'd have to go in there, unfix them, and then start monkeying with it. But it's a quick, hey, just hold everything still for a second so I can take a look at what's going on. And I still have an error, and I still have an external reference. If you're not sure what it's talking about now, because I went into the sketch and I got rid of the external references, what is going on here? So if I say what's wrong, it says one or more external references is missing. That doesn't help me out. Okay. There's two different things that happen when you put in an external reference. Let me go back to the assembly, because typically you don't even really see the external references happening. I don't know how many external references are here. That's because in recent versions of SolidWorks, they turned off something called update holders. If I right click on my feature manager tree and say show update holders, at the bottom of the tree it'll show you which parts have updates that need to happen. So when I click on this thing, it shows me this part is still referencing something in this assembly. When you create a new part inside of SolidWorks, you have to start a sketch plane, right? First thing you usually do is you start a sketch. What I used here is I used a face on one of the parts for my sketch plane. And that's what's getting my external reference. So if I go into here and I say, rather than edit sketch, I want to edit the sketch plane, here's the problem. There's a missing plane. It doesn't know where it's supposed to start because it used to be on the bottom of the engine. But that's not the same face anymore because I changed out the cylinders. So all I need to do is delete this thing that it's got and use some other sketch. And now you see all my external references are gone. So to get rid of an external relation, there's couple things you can do. You either need to go into the sketch and get rid of dimensions or relations like on edge or offset that are from geometry in the assembly, but you also have to go into where's that sketch being drawn on. Is it an actual plane inside the part or is it some face that's in the assembly that we're using for the sketch plane? Once you're finished with the external references, stripping them out of there, then you have something that you can put in without having to worry about the errors later on. And you can see that now that it's no longer starting off of that face, I need to put it there myself. Okay, and with getting rid of those, now I've got this assembly. Everything seems to be working on it. I have no more errors. Okay. Before I get out of here, though, I did want to talk a little bit about the top-down designs, because anytime you design a part in context of an assembly, you're going to end up with those external references. The best way to clear them out is to never have them in the beginning. Right now, I don't have any. Remember, I showed those update holders, but there are no update holders now, letting me know that there's no top-down parts. I want to build something in this subassembly. I'm going to click on here, edit this subassembly. So I'm actually working in this subassembly while I'm looking at the rest of the assembly. And I'm going to insert a new part. So it asks me for a name. And then it asks me where I want to place it. A trick that I always do when I'm putting in components into something is I don't like to just pick some face on the part. Whatever face or plane I pick right now is going to be the front plane of my part that I'm inserting in here now. Usually what I like to do is I like to pick on the front plane of whatever I'm putting it in. And then I'll have the same 0, 0, 0 for my new part as for my assembly. When you drop it on the front plane, it drops it onto the front plane at the origin. That's where your sketch starts. Because I actually don't want my my sketch starting there, but I usually just start a blank one on the front and then actually sketch one later. Okay. How to get rid of external references is to never have them in the first place. That's what I'm getting on my message here. If you look at my toolbar up along the top of the screen, this button right here, no external references, I have that pressed in. It's off by default. But if you have it turned on, what it'll do is it'll allow you to grab geometry out of the assembly, but it won't put that permanent reference in there. It just grabs it. It's a one-time thing. It has the geometry at the size it was when you grabbed it.
Does it fix it in space?
No, it doesn't. I'll show you. So the question was, does it fix it in space? And you'll see that it does a couple things. First off, it gives me an error. Thanks. There's a lot of geometry going on here. Sorry about this. There we go. It tells me it's automatically going to be broken. All I can say is okay. But you'll see that it's blue. It's underdefined. So if I click and drag on it, it goes anywhere. But for right now, it's perfectly where that part was, or where that geometry was, if I don't move it. And what I'll usually do is I'll go into this part, edit sketch, just do a fully defined sketch. It puts whatever dimensions it needed to get that locked down into the location it was in. So these numbers right here are exactly in the position that I grabbed off of the assembly. And I can change them now if I want. I have dimensions, but they're not going to update. If I go into the assembly and start moving those pieces around, this isn't going to care because I don't have that external link anymore. But it's one of those things, you know, when do you actually make that break of not using external references or using external references? I try to not have them in there as much as possible. As I had stated already, they are a really powerful tool when you're in the research and development side of your design. But as you start locking it down, it's a good idea to start removing those. But now I can see I've got a part and I don't have one of those update holders at the bottom because I broke the link to it. In fact, if you look at this part, it has references that it lists, but they're broken automatically. For the sketch relations, there's actually no sketch relations in here. Why it's getting this external relation actually has to do with where this sketch is. If I show this sketch, and I'll do a measurement from here to there, tells me they're 80.8 away. I'm going to create a plane 80.8 away. And I will move this plane to before the extrusion. The thing is that where I started this sketch was on the face of that part of the carburetor. And that's why it's giving me that broken external reference, because it used to have a face that it knew there. It was good enough to break the reference so it won't continue looking for where that plane is, But that's what's giving me that little mark. If I go in here and say, let's edit the sketch plane, instead of the missing plane, I want to put in this new one that I just created. And when I go into the assembly, I've got this piece here that's exactly got the distance between those two pieces on the carburetor. I just need to go into the subassembly itself and locate them where they need to go, because right now they're free to move. All right, so it's a little bit about external references and how to get them or not get them, depending on what you're after. And again, you need to get rid of them at some point near the end. So it's a good idea to just get rid of them while you're going. Okay. I just have one more example that I wanted to show you. And I have to say, I did steal this guy's example. There's another guy on YouTube with the name Lars who does SolidWorks videos, so I had to watch it, see what it was all about. Some Danish guy, and he did this bit. I'm stealing it from him directly because my name's Lars too, and I figure we're in the same club. But since he was from Denmark, his had a Carlsberg beer. I've got the Anchor Steam because I'm here from California. What I want to talk about is file references. So we were talking about external reference before. That has to do with geometry, one file looking at the other. The file references, when you go to open an assembly, you know, there's that list of files that you need. And if you can't find any of them, it'll say, I can't find this. Would you like to find it yourself, etc. There's something called a recursive search, and it's how SolidWorks looks for a file. It does not actually always go to the folder that you think it's going to go to. If you have a part open in RAM, that's good enough. It'll stop looking. So I've got this part called cap. I'll go in and find an assembly here. Here we go. And you can see in my preview, it's got a nice little red gas cap on it. Perfect. In fact, before I open it, let me just take a look at what's going on here. Whenever you're opening an assembly and you want to know what's going to be loaded onto your computer, before you hit open, hit references, and it'll show you all the files. So here's the files and where they were last time it saw them. If you want to redirect where it's getting a part, you can double click and change what reference it's going to get before you even open it. It's kind of tough doing that because when you do something like that, it will put the part in there, but there's no guarantee that that part's going to mate correctly. So you might end up with a bunch of errors because you got to fix the mates from the part you swapped out. But I'll just say, okay, that's fine. I got top and bottom and the cap. So let's open it up. Okay. This is what's up with that internal ID. Right away it says, hey, I found the cap, but it's not the one that you started with. That's fine. Just show me what I got. What? That cap's not going to fit on there. Okay, that's what happened. So when SolidWorks, it was looking for 3 files. It was looking for 700-01, 700-02, and it was looking for a part called cap. Because I had a part called cap open in RAM, it didn't even bother searching for it. It was like, oh, I've got it right here. Bam. It's nice that it gives you that warning about internal IDs, but if you say, don't ask me again, you might not have even known that happened. Because if you say, don't ask me again, it's just going to open it up like that. If this was an internal part, like bolts inside of a box or something like that, and I just swapped them all out, I have no idea that that happened. So you do want to be careful with that. This one I have an idea it happened because none of the faces are able to mate anymore. Now what you don't want to do at this point is this. Go Because when I hit save, you know what I just did? I just rewrote the path for the cap. It's always going to open up this cap now. I'll prove it to you. I hit R. Still got the red cap in its preview, but it's opening up the cap. It doesn't even give me that error with the internal ID anymore, because now that's the internal ID it thinks I'm looking for. Okay, I showed you the fact that you can go file open, hit references, and browse to a new location. And I said, you typically don't want to do that because of mates. In this case, what you can do, what you'd rather do than doing that, is find the part that you want to change, right click on it, and you always have to go to the second page here to find replace components. And then I can browse for whatever part I need. There's my gas cap. Let's open that. This next page, this is the important one. For me, it's saying it found those spaces because I'm actually using the exact part it was looking for in those mates, which was like, hey, great. This concentric goes on this face of the cap. Coincident goes on this face of the cap. If you bring it in with a part that has different geometry or different face names, like you've designed it in a different way, instead of these things being a green check mark, there'll be a red X, and you have to go through and you'll just solve each mate one at a time. Sort of like I was doing in that error thing where I listed all the mates, only it's much more intuitive because I don't have to go mate by mate. It'll go to the next one. It'll show me pictorially, hey, this is the face I'm looking for. Pick the corresponding face on this new part. So it's always better to do, if you're going to swap out a part, to swap it out with that replace component while the assembly's open, rather than trying it from the open, because usually when you do the from open, your mates just explode because it can't find all the faces and edges that that part used to have. Okay. So how do you get around this? Don't name stuff cap, pin, gear, wheel. Those are terrible names. All you need to do is put your initials at the end, put today's date at the end, put some modifier where nobody's going to get that same combination of letters in there. The best one would be to use a GPN, because if you have a real part number, obviously nobody's going to duplicate your part number. But if it's a placeholder and you're still in the development side, give it a name. Just don't give it a really stupid basic name that somebody else might have used. You're going to run into problems like this. Also, when you go to put it in your vault, if somebody else has already used that, you won't even be able to check it in, because it'll be like, oh, there's already a part called cap. Sorry. So it's just, head that off at the pass. Let me quick check the dory, because we do have some people watching. But if you guys have any questions, just go through the dory, or I guess that'd be the easiest way. That was the meat of my presentation here. I did just want to do a few of them that are basic mistakes that people make all the time. How to avoid them, or how to know what happened. One of them is opening a sketch on an edge. So typically when you're sketching, if you pick a face and you start a sketch, of course that sketch will be on that face. The thing that gets people in trouble is they think they picked a face, but they picked an edge. And then they go, okay, I'm going to draw on this. Wait. That's not on the face I thought I was. But get out of this sketch. What? Why is there a plane there? Why am I drawing here? What's going on? What's going on is when you pick a face and hit sketch, see that red L? Obviously, it sketches right on that face. If you pick an edge and you hit sketch, what SolidWorks does is it creates an edge, creates a plane perpendicular to that edge that you picked at whichever endpoint you were closest to. So if I had picked over here, my face would have been there. But that one will happen to a lot of people where, how did I even get all these planes? Or why aren't I drawing where I thought I did? make sure you hit the face when you press that. Another one that's very common is that one right there. I didn't say what I was going to do, but you guys know what I did right there. Yes, I hid my solid. This one happens to me, or happens to people all the time. They come up to me and they're like, where's my part? I can't see anything. Even though I can see all the features and I tried doing a control Q, nothing is happening. Okay, what most likely happened if your part has become completely invisible is you accidentally hid the body. And it's pretty easy to do because it's on a pop-up toolbar. That's why I was able to do it so quickly. If we go into this pane right here and expand the solid bodies, that's supposed to be yellow, or blue rather, sorry. So you want to make sure. And what I did was when you click on it, if you hit that one, that body gets hidden and you really have no idea where it went. It's still there, just you can't see it. I had talked a little bit about this in the past. Let me just quickly create an assembly here. Because this one will happen more often than not to unsuspecting SolidWorks users, where they'll get a problem where they're looking at their assembly and then they hit fit screen and everything goes away. Where's my assembly? What it is, you've got a part way far away from another part. So when I was in that sketch and I couldn't see my problem, I hit the fit screen and zoomed way out and I could see everything that was in the sketch. It's kind of the opposite thing going on here. You're in your assembly, you hit F, all of a sudden your assembly, you can't even see where it went. What happened is you got one part over here and then, 300 meters away, you have another part here. When you zoom out to see both of them, you can't actually visually see them. If I didn't have my origins turned on, I might not be able to locate those on the screen depending on how far they are apart from each other. When you've got something like that, typically what I'll do is I'll find a part that I really know where it should be and I'll zoom into it just to make sure that I don't have that hidden body thing. That, yes, I can see that. And then just start figuring out, when you click on something, do a fit screen, you can figure out where they are in relation to one another. Okay, and the last two that people will get hung up on have to do with selections. Notice that as I'm hovering over here, it's showing me edges, faces, vertex, depending on where I pick, and it highlights yellow in the screen or an orangish color. If I go into my options and turn on dynamic highlights, it's this one. And for some reason, I've seen this get turned off on people, though they swear to me they did not turn it off themselves. So I'm giving them the benefit of the doubt. It has never happened to me. But now you'll see that as I'm hovering over here, I don't know, am I over an edge or over a face? That can be pretty aggravating. If you're trying to pick an edge and you're like, is that the edge? No, that's the face. Okay, is that the edge? No, that's the face. Okay, so where that is, again, you can search for stuff. It's called dynamic highlight. Yeah, spelling counts. Try that again. Dynamic highlight from graphics window. It's under your display selection. It's this one right here. Okay, and the other one that drives people batty is this one right here. The little funnel. Anybody ever seen the little funnel next to their cursor? Okay, what is the little funnel and why did it happen to me? It's called a selection filter. So if you've got something that's very busy, where you've got edges and faces and vertexes all piled up on each other, especially if you're in like wireframe or something like that. And as you're moving your cursor, you're just picking like 15, 20 things, just moving it around a little. You can turn on a selection filter. F5 is the hotkey, and I can filter out just edges, faces, but here's the thing. V, E, X. That's how that usually turns on. You'll hit one of those letters. Where if I hit V, I thought I was copying and pasting something, but I really just hit V. Now all of a sudden I've got that, and it won't let me pick anything but edges. Sorry, it was E is E for edge, V is vertex, and then X is just faces. So if you ever see that filter come on, you could start pressing EXF and see if that's the ones you did. Or the best thing is always just hit that F5 because this is a global, turns them all off. Hit F5 again, it goes away. And it is useful, actually. I use selection filters when I mean to. It's very useful. When you do it by accident, I can see that it's aggravating. But those are some of the ones that I've seen people, I get those questions all the time. Do you guys have any questions for me on any of this that I covered? Check, I gave them a chance on the Dory. No Dory questions? Okay, then I guess we're done. Thanks for coming. This will be posted. I'll send out a link for it. Next month, we've got a class on SolidWorks electrical schematics. So kind of a niche program, but thanks everybody for coming, and we'll see you next time around.